You sure you don't have any questions? Once I leave this, I leave it. I'm not gonna go back to this. So I don't waste my time like asking dumb questions to kill time because whatever I don't teach you, you have to teach yourself. So like legitimately think about what you're gonna ask me. Any questions? One last time. Going once, going twice.
All right, so the test will be on Tuesday or Thursday.
Next week, Tuesday.
Okay, sir.
Anybody else?
We continue the videos.
I have not had any time for videos, man. I'm not even joking. Like just just answering emails and questions. I don't even think you understand how many people email me. And it's not just your class. It's not just your class, right? The number of emails I just have to answer, ask questions, that people ask questions is just overwhelming. Then I have stuff to grade. All right. So like I've already given 3 quizzes in advanced web. Uh, we've had 2 quizzes in programming one. It's gonna be a third one tomorrow. You have your quiz, and then I have that ridiculous intro class that I have to deal with. So it's just like I don't have any time. Like uh, we're like I could tell you from same thing with other lectures. We're up until late at night, just trying to catch up. Like it's ridiculous.
Sir,
Yes.
the topics will be what you teach. Like, will this topic that you will be teaching today, will it be included?
No, 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 no. Its first test will be strictly on linked list. Nothing new. All right. I might do a short review on Thursday for the test on Tuesday. All right, guys. So
So the review will be after the test, not before.
no, today's what? Please tell me that is not Thursday. Today's what? Tuesday.
Tuesday.
Right. So I said on Thursday I'll give you a review.
Oh, I thought next Thursday after
No,
the
no,
test,
no,
like the quiz.
no, no.
Okay,
This
fine.
time I'll be nice. I'll give it before. All right. So next topic is stocks. Now, I already explained to you what stocks are. I try to give you a visual. I told you to imagine a cafeteria where you have a stack of trees. Right. Let me see if I can get back to my awesome drawing. All right. So where's my pen? Where's it? Sure, I don't see it. Okay, there. So imagine this is your stack. This is all sealed, 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 right? The only part that's open is the top. So let's pretend I have this like spring
Sir, I
here.
see your
Yes,
screen.
yes.
I can't see your screen.
Oh, frig, sorry, dude. Uh, Thank you for that. It's kind of like could have been pointless for me to be drawing on share screen. All right, back to this. Okay, so stack. So I told you what a stack is before. I said so a stack is. Come on, pen. Like this, right? So this is sealed. All of this is sealed off, right? You can't get into this stack from here or here. The only part that's open is up here. So imagine that there's like this little spring here, and then these are trays, right? Trays that you put your plates on, right? So they're all placed one on top of the next. So if somebody works in this cafeteria, right, and they're responsible for dishes, they clean it, right? So they have in their hand, they have a pile of trays, right? They have a pile of trays. The only way they can load these trays would be through this point, all right? They can't put it here. They can't like take this one up, stick it in there or here. Nowhere. It has to be placed like this. So the last one that goes in, right? The last one that I put in will also be the what? First one that comes out, right? So this is why this thing is called a LIFO structure. The last in is the first out. All right. Whereas the first guy who went in will be the last one that comes out. See that? That's the first one that went in. So the last one that goes in will be the first one that comes out because, as I mentioned, it's very critical. A stack only allows operations on one end. You can't do operations here or here or here. They can only happen here. All right. So that's what a stack is. The official terms. Now let's talk about the official terms for inserting into a stack. For a linked list, we said we call it inserted front, inserted back, remove from front, remove from back, is empty, so forth. But for stacks, there are two words that we always associate with stacks: push and pop. Push is when you push items onto the stack. Think of as inserting. Push is equivalent to inserting, and pop is the equivalent of removing from a stack. All right, those are the two operations: push and pop. We can also ask the stack, are you empty? All right, and it's the same principle like a linked list. It's just going to check, do I have any items within the stack? But there are only two major functions involved in a stack: inserting and removing. There's no inserting at the front, the side, the back, none of that. It's just one direction in which information can be inserted, and only one way information can be removed, right? So push means insert, pop means remove. Any questions so far about this?
Would you say that this data structure is easier to understand than linked lists, sir?
No, I don't think so. You have less functions. True, yes, 100% you have less functions. I guess because of that, right? Maybe just because of the reduced number of functionality.
Yeah, because it
associated with
seems
stack,
really
it might be
simple
easier.
right off the bat.
Huh?
Yeah, because it seems like really simple right off the bat, just like pushing and popping.
Well, in that sense, yes. In that sense, yes. Because if you notice, those functions asked you to do for the quiz, those are just random things that I thought about, right? And the program that I give you, the first program that I give you, just be a bunch of functions that I thought about that would be cool that if you could add to a linked list, right? A general linked list has only the functions that you saw on the slides: insert the front, insert the back, remove from front, remove from back, is empty, and print. Those are the standard functions associated with a linked list. I gave you 3 additional functions, and for your first program, I'm going to give you an additional maybe 10 more to do weird things that I would want a linked list to perform. But I cannot do that with a stack. I cannot say, hey, I want you to create a function called something that allows you to insert in the middle. You cannot. The minute you can insert in a way that's different from what a stack says, it's no longer a stack. Understand? The rules of a stack are very clear. The minute you violate it, you're no longer a stack. A stack says insertions only happen at one point and removals happen at one point, same point. All right? No other way. So in that regard, you're right. A stack is less complicated because there's less functionality to consider. Okay, any other questions? No. All right, I gave you a whole video about memory locations, about the stack and the heap and the code segment and other things, right? Initialized variables and uninitialized variables and so forth. I explained to you that in a program, in a video completely in detail. So you saw how a stack is used, right? Because ultimately, under the hood, those things that I showed you with, for example, when a function calls another function and then that function gets placed onto the stack and his variables are active variables, and when that function ends, he's popped off, and that's how we keep track of who calls who. Because you have to think about this as well, right? I always tell you, when a function calls another function and that function ends, where does it go back to? It goes back to his caller. But have you ever considered, how does the program know who the caller is? So actually, under the hood, that mechanism of determining who called another function, that is determined by the usage of a stack. All right. It's also used in generating machine language code, evaluating expressions by compilers. So that's used heavily in that. For example, when you compile your stuff, all right, when you compile your language, your C++ or whatever language it is, under the hood, stacks are being used, right? Stacks are being used to determine, for example, oh, you opened up a curly brace. Where's the closing curly brace? That's an error, right? So again, stacks would be used. Check out your browser. If you go to, let's say, 20 pages on your browser, and you decide you want to go back, how on earth does the browser keep track of who the previous pages were? All right. How does he know what the previous pages were? So in that case, a browser uses two stacks. All right. So for example, let's show you. So a browser might have a stack called, I don't understand this thing. Front and back. All right. So every time you go to a page, that web page will be placed here. All right. Go to another page, it gets placed here, gets placed here, gets placed here, gets placed here, right? So now you started off here at Google, then you went to Hotmail, then you went to Yahoo, Gmail, then you went to, hold on, let me add this person. Then you went to Zenagrid. Now you want to go back, what happens? I'm at Zenagrid, I need to go back to this point, I think this was Gmail, right? So what's gonna happen is I'll pop this off. I will pop off this link and I'll put it there. So this is gone, and now back at Gmail. And if I pop off Gmail, it's gonna appear on this. And then when I'm here, if I go back, I could just go back and forth between these two. You understand? So this is how a browser would keep track of which pages you visited, and they can go back a certain point. All right. And if you notice, like if you click the back button on your browser, but you hold it down, you don't click and release, you click and hold it, you'll see all the pages that you visited in that particular session, right? How does he do that? Under the hood, he's using a stack, okay? All right, I see some questions. Let me see what.
So Mr. Rabani, this is the reason why memory is being used a lot by Chrome or the.
Oh, it's not just that.
Not
Some
okay.
people, that's part of it, but some people don't realize this, right? Browser might seem simple to people. Oh, you just show me what page is. A browser is one of the most complicated applications running on your machines. All right, it is nothing trivial, nothing small. All right, it's a massive, complicated application running. Okay, so it definitely uses a lot of memory, but a lot of things are happening. All right, people just think, oh, it just shows me the web page. Whew. It's nothing like that. All right, it's nothing like that. A lot of things happening. A lot of things happening in terms of just networking, in terms of just evaluating pages, elements on a page, just orienting things when you maximize, minimize, just so many things happening. All right, it's a very complicated application. All right, and this is why you'll find a lot of companies try. They've been at war. All right, these companies, Microsoft, Apple, and Google, they've been at war. Netscape was the original daddy of all of these people, but they've been at war trying to produce the browser that everybody uses, because that's like the gateway drug, right? Once you get in, use the browser, you're going to use this and this and this for that company and so forth. And that's why Microsoft basically lost that battle to Chrome. And then Microsoft said, okay, Microsoft is damn smart. I like them. Microsoft basically said, all right, so our Edge sucked. It had problems, or it didn't suck. Yeah, we just couldn't get the same traction. People prefer Chrome. And since Chrome was made open source, you remember, no, you know the drill, guys. Once this runs out, we're just going to start the same session. When Chrome, because Chrome is open source, so Microsoft just took Chrome's code base and they built the new Edge. All right, so you can't say now, so Google can't say, oh, Edge sucks, use Chrome. Because if they say that, they're basically saying Chrome sucks. because they're using Chrome's code base. All right. So I actually believe that Microsoft's browser is now more superior to Chrome. So let's see where that goes, because that just puts people in competition mode, right? It's better for us. All right, guys. So does that make sense in terms of stacks? Do you get the general idea of what's going on? The stacks?
Yeah, it makes sense.
All right.
Yes,
So
sir.
if I asked you, how would you, if I gave you a linked list, right? If I gave you a linked list and I said, can you convert your linked list into a stack? Like, which functions would you keep from your linked list so that it acts like a stack? Because if you think about it, right? If you think about it, I draw stacks like this, right? Just so you get an idea, but it doesn't matter, right? Let's draw it horizontally like this, right? It's the same principle. You can't add here, you can't add there, you can't add there. You can only add from here and remove from here. So if this is your stack, you can say this is like a linked list. Which operations or functions from your linked list would you keep and which would you remove in order for the linked list to act like a stack? Tell me.
So move front and move from, insert from front and insert from back.
What would you do with those? Keep those or remove those?
I'll keep those and the rest will be removed.
So you're saying from the linked list class, the standard functions. I'm not talking about all the crazy ones that I asked you to build and you're going to have to build. I'm just talking about the standard functions. The two functions we would need to keep so that the linked list behaves like a stack would be insert at front and remove from front. Is that what you're saying?
Insert from front and insert from back.
Insert from front and insert from back?
No,
Yes, sir.
no.
But then if you
What
can
you
insert the
said,
back, that means what you're saying,
then
what
you
you're
could.
saying is, where's my pen? What you're saying is I can insert here and here. Is that how a stack should behave? I just took this, look, you see this? This is my stack, right? I just tilted it like this. I just went like this. They became horizontal. That is right. It's the same principle. You can't insert here, you can't insert here, you can't insert here. You can only insert in one direction. You can only remove from one direction. So from the perspective of a linked list, which functions from the linked list class would you keep in order to represent those operations?
Insert from front and remove from front.
Okay, insert at front and remove from front. Correct. And there's only one other function you'd really need, which would be
Is empty.
is empty, because this is a feature of a stack as well that's necessary, right? A stack needs to be able to tell its users whether or not it's empty, all right? Because you do not want to be removing values when a stack is empty. So you need some type of mechanism in order to tell users about its state. So basically, what I just told you, that means I can build a stack class, right? And I just have to do what exactly? I just have to remove, so I can take the same list.h file, right? Take your same list.h. Just I want you to start work with me right now. Imagine this, right? So imagine this. You have the link, the list.h class. All you have to do is look for the function that says insert at back. Highlight it, delete it. Search for print. Highlight that function, delete it. Search for remove from back, highlight it, delete it. What you'll end up with is empty, insert at front, remove from front. All right? And all you have to now do, I don't know if you're following this thing in your head, like if you're imagining it, all you have to do now is rename insert at front to push. All you have to do is rename remove from front to pop. Done. You have official, and of course the list class will now be named stack. And you're done. You have now built yourself a stack using the exact code from the list class. That means that ultimately a list is a restricted form of a what? Stack. That's what it is. Sorry. Let me put it in reverse. A stack. Sorry. A stack is a restricted form of a list. Okay? Because a list has many more functionalities. But if we remove a majority of those functionalities and we keep only the ones that we want, you end up with a stack. Does it make sense what I just told you? Is everybody understanding everything so far? Yes, no?
Yes, sir.
Because we're about to how can I say this? We're about to put hair on your chest. And those of you with no facial hair, hopefully by the end of this session, a few hairs will start to sprout. All right. And for the rest of you, maybe your voice might actually start to change. All right, which is good. So as I go through this
And
part,
for the females,
I'm not going to comment. I have no idea what the effect is on females. So,
The same.
huh?
It won't be the same.
God, I hope not. I hope not. Damn it. I wouldn't want to see these females in this class with a beard walking around. It's kind of. So, yeah, I don't know what the effect is on females. So you guys can tell me what happens to you guys afterwards. But for the guys, yeah, if your version of shaving has been so far using a tweezer, then hopefully by the end of today and the rest of this week, you might be able to now invest in a razor. All right, so good for you guys. Here we go. So we have 2 minutes. I'm going to teach until this thing runs out. So I want you to look at this code. Take a good look at it. Try to make as much sense as you can from this code. Don't go, man, I don't understand this. I don't understand it. Don't worry about that. Don't worry about what you don't understand. Look at it and see what you do understand. And then I'm going to ask you questions. So look at it carefully. All right. Okay. Do you guys think you know what's going on in this code? I don't mean like tell me line by line, it does this. I'm asking you that. I'm asking you, looking at it with your programming background, with what you've seen so far, can you make an educated guess as to what this code is all about? What's happening here?
Yes.
Okay. Most people, is that the case for most people? Yes. All right. So what I'm going to do is I will slightly go off track because what you're seeing here is an example of inheritance, right? I need to explain that this is a topic that you will actually spend a lot of time in the object-oriented